Thank you and welcome. And it's my pleasure to introduce Bryant Nielson, our speaker, who has been wonderful and so accommodating. Couldn't be easier to work with.
So my name is Bryant Nielson, and I don't like the title CEO or president, but I'm the executive director and founder of the Blockchain Academy. And I've been running the Blockchain Academy for 2.5 years. Blockchain Academy is actually a part of another company I own, which is called Capital Wave. And we do capital and wealth market training for investment banks and hedge funds in New York City and London. But how I came to start doing programming and training on blockchain was we had a client come to us and say, hey, we hear this thing about blockchain. Can you do something about it? Give us a course on it. And I'm like, yes, of course. Not knowing anything about it outside of just my initial introduction to Bitcoin that had been existing in the public arena. So the problem is that blockchain is a real technology. And oftentimes what we do is we find ourselves confusing what blockchain is. We know that blockchain is a part of Bitcoin. And I want to ask a question. How many of you, first of all, have heard or know of Bitcoin? Good. Excellent. How many of you are comfortable with understanding what blockchain is? Fewer. So the issue is that Bitcoin itself has provided us with a lot of the fire and ice of the excitement that surrounds it. But as I'm going to share with you, what we're going to find out is that it is only a small part of the opportunity that actually blockchain presents. So I want to start with this one, and this is that the blockchain is the most consequential technology since the internet. The internet is programmable information. The blockchain is programmable scarcity. What this is trying to share with you, I have like dozens and dozens of these things, but the one that the reason why I chose this one for this presentation is because it really kind of isolates and identifies what is really the most important aspect of it. Oftentimes people think of Bitcoin and blockchain interoperable. They're not. To me, Bitcoin is something that sits on top of blockchain. So it's just an application like many other applications. But I like to think of blockchain as really the full embodiment of what we would think of as Internet 3.0. Everything, we couldn't have blockchain without the internet. But now that we have the internet, how are we going to build upon it? And that's really where blockchain comes in. So as we kind of look across the horizon, what we start to see is that there's a lot of opportunities, and we want to look at some of the things like adoption rates. So one of the first things that we look at is the activity of blockchain in terms of trends. And as you can see, this is the red line, of course. It's going off the charts. And this is actually up till 2018. I would say that it would continue its upward trajectory if I still had updated this particular slide. But even more so, here's another chart where we're looking at adoption rates of different types of technology, things like telephone and radio and color TV and internet. And as you can see, it takes a number of years before you actually start to reach 100% activity level or adoption by the populace. And over here on this green chart, what you're seeing is what is the current cryptocurrency market value? Now, obviously, that's dropped way down, about 70% since the beginning of the year. What was very interesting is I was speaking in Moscow right when it hit the 20,000 mark. And that particular conference was electric. Everyone was like, I am so rich. I'm Lamboing everything. So, but it was very interesting because by the time I flew back, it had already started to fall. And of course, by mid-January, it had almost collapsed. So the first question a lot of people ask is, well, what is blockchain? Blockchain is really an interesting thing because the first thing it is it's a distributed database. And so think of a giant global spreadsheet that runs on millions and millions of computers. It was actually Alex Tapscott who actually said, think of it as Google spreadsheets. You have the ability just to have something that's on the cloud, and you can actually engage with it, with one another, irrespective of where you're located. The other aspect of it is that it's open source, so anyone can change the underlying code. That's the beauty of, at least currently, of blockchain. It's all published, so everyone can contribute to improving it. Now, the irony is that sometimes we improve it, and sometimes we take things away. So as an example, Ethereum was, when it was first started, it is actually Bitcoin code. And what they did is they took and added back something that Bitcoin took out. Bitcoin Core is the group of people who actually manage Bitcoin, took out in 2011. And that was this thing called smart contracts. And then what Ethereum did is what they said, let's improve upon it. Let's create a scripting language, and let's make that smart contracts the centerpiece of where we think that the future is. That couldn't happen unless it was open source. And so currently, up till now, all public blockchains or all blockchain technology is fundamentally open source. One of the things, though, that it requires is the use of cryptography, and that is to act as the authenticating source, proving that that the transaction is valid. Now, it's only valid up to the point that there's a consensus that's reached on it, but these are the elements that you should be always thinking about. It's a distributed database, it's open source, there's a requirement to authenticate and settle transactions, and they're using cryptography. So this is really then, what is a blockchain? It's a distributed group of servers. It's not locally centralized. It is permissioned, meaning that you either have, there's three types of blockchains out there. There's permissioned, which means that you have to be invited to go there. Permissionless, which is like the Bitcoin or the Ethereum blockchain. Anyone can participate. Or a hybrid, where part of it is permissioned and part of it is not. So it's permissioned. It's secure because it's using, by the way, you don't have to take photos. You can have a copy of this deck so that you get it in its highest clarity. It's a secure database, meaning that it's using cryptography to actually manage the security. It's trusted simply because everyone is going to do it through consensus, and that consensus mechanism is the most important aspect. I didn't used to think that consensus was so important. And then I started doing a course on consensus mechanisms, and I realized how important consensus mechanisms are. They're as important as every other aspect here, especially when you think of cryptography, using the underlying language, the choices of available attributes or DApps that you can put on to a blockchain. Consensus is an amazing component. And we actually have consensus blockchains out there where you can have multiple consensus mechanisms depending on who the users are. And I thought that was fascinating. And of course, the last part of it is that it's automated, and we actually treat that automation through the source of smart contracts. So really what I wanted to do is that there's a fallacy out there about when blockchain began. So I'm going to give you a little origin story here. So in 1978 was when we first came across what we now know as RSA, which is the current aspect of understanding cryptography. It was actually after a drunken night, these three guys got together and they figured out how to separate the public and private key. If they hadn't been drinking, they would have not been doing it. So I'm not a drinker, so obviously I'm not inspired enough. But then that was followed up, so that's how we get RSA cryptography. And that was then followed up in 1991 by a guy named Stuart Haber and Scott Storinetta. And they're the first ones who actually created a secure block using cryptography. They built the first blockchain. And what's really interesting is that actually Stuart Haber has just joined as an advisor of another company. And everybody was like, well, who's Stuart Haber? Why are we so impressed with him? And I'm like, I know who this guy is. This is the guy who actually created the first blockchain. In 1992, he introduced something that was new to this idea, because previous, when he first created it, one transaction per block. Then he created this idea of a Merkle tree. And in 1992, that Merkle tree was then incorporated so that you could have then multiple transactions built into a block. He didn't have all the problems solved because he didn't have the cryptography. That had to be done before, but he built the first blockchain. The next aspect of it is Nick Szabo. And what he did is he was the first to actually use 3 elements of creating a blockchain. Now, by the way, Nick Szabo has been attributed to being actually Satoshi Nakamoto. And I'm going to tell you about Satoshi Nakamoto in just a minute. But he designed the mechanism for using a digital currency using cryptographic blocks and a consensus mechanism, meaning how are you actually validating these blocks? In 1998, then what we started to do is we started to see how these, that was actually in 1978. In 2008 is when we actually started to see Satoshi Nakamoto's white paper, and we just had the 10-year birthday of it on Halloween. So October 31st, 2008 was when he published his white paper in a very obscure MIT cryptographic newsletter. And then in 2009, what we started to get is we first started to get Bitcoin. So when people say to you, when was blockchain created? You can actually say it was in 1991. Merkle trees were added in 92. 1978, you had RSA cryptography. And you started to then seeing how it was being created in 1998, a full 10 years before Satoshi Nakamoto actually wrote his white paper. But if you look at the footnotes of the white paper, all of these people are referenced. So then the question is, well, what's the history of cryptography? Because this was obviously something new, right? And the answer is wrong. So in 1982, we had our first electronic cryptos in the form of eCash. And what we had is a system of micropayments. You got to remember, in 1982 was right when we started to have a great adoption of credit cards. And he wanted to say, you know what, I like this idea of credit cards, but maybe we should do it a little bit different. Let's make it digital. And so that was actually the first crypto that was created. In 1990, what we started is we started to see him write a paper on anonymous electronic money transfer using RSA technology. This happened, again, almost 30 years ago, 35 years ago. In 1996, what we started to see was we started to see e-gold. And that was unique because what had happened was you could then deposit your gold. Gold is very hard to transport. It's also not very divisible. So you could take your gold, put it in a central repository, and then you could then trade it in any fractional aspect that you wanted. That worked really well until the government realized that's how a lot of criminal behavior was actually managing the transfer of their payments back and forth. Then in 1996, then we had the Liberty Reserve, and Liberty Reserve was basically the same thing in the US, and what we started to see at its peak, it was actually transacting $5 million a day back then. They had a little over 250,000 users, active users on a daily basis, but it was also shut down due to criminal behavior. Then in 2006, what we ended up with is the first, this was, I'm sorry, I'm confusing myself because I just changed this last night. So we had a publication of B-Money, which is an anonymous distribution electronic cash system versus one that was centralized and managed. And of course, that gets us then to 2009, which is when Bitcoin actually had its birth. Its birth was through this anonymous person or persons under the name of Satoshi Nakamoto, which is a common name in Japan. And it was published again on October 31st. So some of the things, the birth of Bitcoin and blockchain as we now understand it is that October 31st, 2008 was when it was published. January 3rd was when the Genesis block of the Bitcoin was actually created. It's, the software was released on the 9th, and on the 12th was the first transaction between Satoshi Nakamoto and Hal Finney. By the way, Hal Finney is another person that they've said he is Satoshi Nakamoto. So now that we at least have an origin story about what blockchain is, let's talk about how blockchain really works. So I'm not going to bore you, but I'm going to have to still give you an overview of exactly what it is and how does it work. So what is blockchain? In its simplest form, blockchain is the core technology behind Bitcoin. It's based, as we now understand it, on the Satoshi Nakamoto paper on digital cash. So that then gets us to the next set of questions. What's the difference between blockchain and blockchain technology? Well, blockchain is a network, a distributed database or permissionless public record of transactions in a chronological order. That's the whole reason why you have these blocks, is because they're time-stamped, so that you actually have a perfect and complete audit trail of every transaction. But the technology is a little bit different. It's an infrastructure. It creates a decentralized digital public record of transactions that is secure, anonymous, tamper-proof, and unchangeable. In essence, it is a shared single source of truth. So let's look at it a little bit more. The blockchain is a distributed database. We know that. It's cryptographically signed for every transaction. We know that. It's accompanied by a proof of work to assert reputation. That's the consensus aspect of it. And it's replicated across nodes in the network. And of course, the important part of it is that there's no master copy. Every mining node has a complete and perfect copy, assuming that they've been online the whole period of time. So, how does that differ from what we know? What we know, at least previous to now, is that we understood this idea of a centralized database, where everything was a single source. It was the shared truth that everyone could access at a single point. And in essence, what you had is everybody on the external part would access this to a single source. And then that got us to this idea of a decentralized system. And that actually became required simply because of the size of firms as they became. So in essence, what you have is that interior ring being a mirror of all that single source. So if you eliminated the biggest problem with a centralized system, and that is a single point of failure. If one failed, the whole system goes down. In a decentralized, the banking community was one of the first to adopt this, is they would then have multiple sources. So if one particular database went down, everything was switched to the other thing, business continued. The operational uptime was paramount. So that's where we got this decentralized idea. But that then brings us to what we have now with blockchain. It's a distributed one. Every node has a complete copy. There is no master copy. Every node has the ability to mine, validate, and verify what is happening in a transaction, or just act as a record, a source of a record keeping. Now, this is the little part of the Merkle tree in understanding what blockchain is. I've refined this over the last probably 2 years, and this is what I come up with. And that is to help people understand how does blockchain actually work. So I'm going to have to look up here to show it to you. Every block has 4 components. The 4 components is the previous hash, unless it's the Genesis block, because there is no previous hash. It is a timestamp. It is a transaction root, and then this thing called a nonce. So I'm going to explain each of those to you. The first 2 are really easy. When you first create a block, what you end up with is a nonce, and it's a string of numbers that actually proves it's a cryptographically secure stream of numbers that proves that this is a valid block, and blocks are built sequentially. So the first thing is how do you identify a block? Well, you identify it by this concept called a nonce. And so how do you actually get to it? So the previous hash is the nonce, is a reference to the nonce. The timestamp is exactly what you think it is. It's the timestamp. Well, this transaction root is, can you believe it? Someone's calling me. The transaction root is really where all the transactions go. And what I have is 4 transactions down here at the bottom. And every transaction is then hashed. So you then have a hash transactions. And then they're combined. So then you have a combination of hashes. So hash 0 and hash 1 become hash 0, 1. Hash 2, hash 3 become hash 2, 3. And they combine themselves up into a transaction root. And since this is all cryptographically hashed every step of the way, you have a complete audit trail, and you can't then undo it. You can't go back to, say, block 8 and change one of the transactions, because all of these things will then change. The nonces will change. The transaction roots will all change. But then once you've built those first three things, you have the previous, the hash, the timestamp, and then now a new transactions route, then the mining occurs for creating the nonce. And really all it is when they talk about mining, it's really solving a mathematical puzzle. Hard to do, easy to verify. Once the nonce has been discovered, everyone can then do the calculations. It's simple, validated. Now we have consensus that these transactions are correct, and now we can start building our next block. And the next block, of course, starts with the previous hash, which is the nonce from the previous block. And then it goes through this process every single time. So Bitcoin actually builds a new block every 10 minutes. And people often say, why every 10 minutes? It's because the way it was designed is that there would be a specific number of Bitcoins that would be issued. And to keep that pace correct, it has to be every 10 minutes. And if we get more machines trying to mine Bitcoin, then the mathematical aspect of it becomes more difficult, so that we maintain that 10-minute increment. But Ethereum does it in every 2 seconds. There's a lot, or every 2 minutes, yes. Okay, so a hash simply is quite simple. It's the mathematical application to the transaction, and it creates a string of 26 characters, and that becomes the hash. It's a mathematical validation to a transaction. So these transactions, as we talked about, one of the requirements for a blockchain is cryptography, and so you're applying cryptography to each transaction. So as you build it up, you're building this legacy system of hashes, which is just really an audit trail. So the idea of this is then what is Bitcoin mining? We actually had a discussion about this a little bit earlier, and that is it important? Absolutely. You cannot have a blockchain without mining a part of it, whether it's a public or private blockchain. So in simple manner, this is the cycle of what a blockchain, how it works. It starts at the top. You have the transaction initiation, where the parties exchange data, documents, or tokens. Bitcoin requires a token. Cryptocurrencies are tokens. Blockchain doesn't require tokens. Blockchain can trade any asset, both digital or physical. Then what you go through is the transaction validation, where the nodes of the networks receive them and authenticate the transaction. You have then a block creation. It's put together. Now there's a competition for block mining. You then have the chaining, which means that the block is then appended to the existing chain. Always the longest chain is the most current chain. And then it starts over. It's just a simple cycle. It's really is not as complex and as this esoteric idea of this mysterious way of creating a block. It's very straightforward, very simple. That brings us to then the type of blockchains there are. Everybody understands what public blockchains are. They're like Bitcoin. They're like Ethereum. Those are the two. I can't say Hyperledger because Hyperledger is a private blockchain. But for a public blockchain, anyone can read and write data. It's distributed, geographically distributed. Its network effect is in play. That is the reason why Bitcoin is the dominant gorilla in the crypto world, is because it has the most number of users. It has tens of thousands of machines trying to solve this mathematical puzzle every time, every 10 minutes. And so that network effect makes it the most valuable particular coin. It's open source. The second one is the other side of it is, of course, is on the private side. And that is different from a public blockchain. And that is because you have to be invited to participate in it. Instead of it being an open for anyone to use, you actually have to be invited to actually participate in it. And there is an issue of privacy. Because of that, now I can exclude you. Say, I can take this side of the room and we're going to create a blockchain and we're going to exclude you because we're only interested in transacting business between ourselves. And then, of course, we have this idea of a hybrid. Now, when we think about these things, it is different from the crypto world because the crypto world, for the most part, resides totally in the public arena. But this private and hybrid arena is going to be probably 10 or 100 times as large as whatever the public arena is going to be. So that brings us to the question of the use of digital ledger transactions beyond cryptocurrencies, because everyone is so focused on cryptocurrencies, they're actually missing what they're actually wanting to see or needing to see. I like to think of this, they changed this picture on me, I was really mad, my staff did. I like to think of cryptos as a beautiful sequoia tree. And how many of you have even seen a sequoia tree? They're the most magnificent trees you've ever seen. They go up 300 feet, they're massive. If they fall over, they don't deteriorate. There's a tree there in California where you can stand on it, and there's a picture of more than 130 years ago of people standing on that same tree. It looks like it fell yesterday. It's absolutely amazing. No deterioration. But they're the biggest trees in the world, these sequoias. That is what cryptos are. What they're not is they're not the forest. There's a huge forest around cryptos. And that is really the big opportunity. If you want to focus on this one sequoia, by all means, do so. But you're going to be missing out on the biggest opportunity that's out there. So blockchain has two primary uses. The first one we know about, trading of cryptocurrencies. But the second is managing and recording of trade commerce processes, tracking, and compliance. So as we start to look at this, what we're seeing is that blockchain, the second part of managing, recording of trade commerce processes and compliance, is you're managing now multiple or millions of transactions. You're managing multiple digital assets, both digital and real. You're looking at operational management. You're looking at risk management. You're looking at regulatory and compliance issues. These are all important issues that actually blockchain has a great ability to solve. That then brings us to this idea of smart contracts. To me, smart contracts is the killer app. We don't think of it as an app because we think of an app as something that has a specific use. To me, smart contracts is the killer app simply because of its capabilities and flexibility. If you're doing anything in your business that requires identity management, that's fantastic. Blockchain by itself can do that. You're doing anything that requires digital asset inventory, that's fine. Blockchain does that. But you're going to need to have smart contracts the moment you move into a supply chain of any type. You're going to need smart contracts that move into anything on the financial side of the business. And by the way, finance has already started the implementation of blockchain. How many of you know what SWIFT is? Okay, SWIFT is this international organization that manages payments, money transfer payments between central banks globally. SWIFT has already moved onto the blockchain. And they've done this simply because of a lot of the hacks. The Bangladesh hack of the central bank, where 80 million was taken away recently, stolen recently. That was prior to the blockchain implementation. And that was simply because of security issues. Blockchain was implemented, security issues, risks went away. It's there, it's here. So let's talk about some blockchain use cases. And I'm only going to just highlight a few of these things because our panelists have some great, I've been talking to them. They have some great use cases they're already doing. But out of Don Tapscott and his son's Alex book, Blockchain Revolution, this is what they've identified. Identity management, vital records, passports, medical and health records. Medical and health records actually have a huge, huge impact. There's some regulatory issues to resolve, but it's going to actually fundamentally change how you have and manage your health. Property management and ownership. You're looking at land management. In fact, land management was one of the very first issues that blockchain was used in Estonia. They were the first to actually put all of their land records onto a blockchain. So now all of a sudden, a burning down of some county court where the records were kept no longer eliminates your ownership record. You actually now have a complete database of it. Voting. Voting would actually be, we've just gone through this. Blockchain would solve every single problem. Not only would we not lose ballots, we would make sure every vote counted. if it was on blockchain. It would also eliminate things that people are concerned about, like double voting and things like that. If we put the entire U.S. on a single blockchain, voting blockchain, you wouldn't even have to be in your state. You don't have to then do mail-in ballots. You just go to any voting booth anywhere in the U.S. and you could vote, and it would count down to your local precinct. Simple, easy, probably not ever going to be implemented.
They did a test in West Virginia. Yep. They did it for the primaries and just the general election.
Well, I'm saying that I don't see how, there's politics involved in this, and so I don't see how it ever be done. But now in education, there's a few sources out there that have created blockchain certifications. One of the biggest expenses of hiring a person is that you actually have to verify that they've actually got the credentials. Well, if you could go to the way it's done now is, okay, I graduated from Clemson. I'm now the HR person. Oh, you graduated from Clemson. I'll have to send a letter to Clemson, and I will have to get validation that you actually did graduate from them, and you did get this degree. Well, the way it is now is you would just be able to take even a QR code, just snap it, boom, there, validation, almost instantaneous. Now, I don't know if the universities are going to adopt that because they do like that $35 or $50 for every person that you try to validate. And that would eliminate that almost instantly. Finance and banking, I think that is probably the low-hanging fruit. There's so many easy adoptions of using blockchain that's what will happen is you won't even know that blockchain has actually occurred. It's going to happen, and you won't even know. It'll be transparent completely to you. Benefits administration, tax collecting, using smart contracts. There you go. Now the government doesn't even have to try. Everything is going to be done through smart contracts. And this is an important one, chain of custody management. So now, getting back to voting, there's an issue about the chain of custody for these ballots. So the idea of a ballot is to make sure that it's valid is that there's always been somebody managing the ballot. It's a chain of custody. Well, there's a problem now in Florida and in Arizona that dealt exactly with that. With blockchain, that would have never happened. This is the current, a very, very subset of the current microsystem of the blockchain ecosystem. And as what you can see here is the following. You can see that, of course, there's an area on currencies, developer tools, you have fintech, you have value exchange, shared data, authenticity, and other. These are the very wide categories. Every sector is being impacted by blockchain. So what you're seeing is that I've done courses on the financial sector, on the insurance sector, on the healthcare sector, how it's going to impact the legal sector, how it's going to impact the accounting sector. These are areas that are going to be transformed through blockchain implementation. This is, though, the key part, kind of a key takeaway for you. And that is that you have to decide what is a useful implementation of blockchain and what is useless. Without making that determination, you're going to find yourself wasting a lot of time and money. The other aspect of it is this, is that there's now multiple blockchain solutions. The way I describe it is the following, is the Bitcoin is generation 1 of the blockchain. Generation 2 is Ethereum and Hyperledger and the Ethereum derivatives, Quorum and Neo and stuff like that. Then what we have is we actually have Generation 3, which were really social blockchains like Steam. Steam is actually a great use of blockchain that rewards writers, rewards people for participating through payments, through blockchain. But it's a social program. But now we've actually arrived at a period of what I refer to as Generation 4. These are the first truly enterprise-grade blockchains, things that can manage millions of transactions per second. The biggest problem that we have, there's two. I'll tell you the second one in a second. The first one is that the existing blockchain platforms are incapable of doing enterprise-grade transactions. If you're going to do anything on the Ethereum, you have to network, unless you're creating a private Ethereum, like using Quorum, which is just a derivative of Ethereum. What you have to do is you have to share all the resources and its capacity with everyone else using it. Now, how many of you remember CryptoKitties from earlier in the year? Okay. CryptoKitties was a game where you traded cats on the Ethereum network. And at its peak, it was consuming 35% of all transaction volumes on the Ethereum network. Now, let's suppose that you are a business manager and you're trying to run your business, and all of a sudden, 2 games come on to the Ethereum network and consume 70% of all the transaction capability. That leaves now only 30% to be shared by every business user out there. Your business collapses. You can't actually do it. This then gets me to the second one, and this is really probably more important than you will ever imagine, and that is there's a coming war for talent. Competition today is not for money or finance. Competition today is for talent. Why is that? All the best minds are working on blockchain now, but there's not enough of them. There are 14 openings, posted openings for blockchain developers right now for every single blockchain developer. When I give a speak at a conference, I am then bombarded by recruiters who come up to me and say, I will hire anybody that you tell me that has the proper skill set, because when I get these CVs in the mail or via electronic posting, it's just fake. There's no validation of it. There's no way to even verify it. There is a huge, huge demand. That's not even going to change. Here's an example. This is a Bitcoin job openings based on compared to crypto prices. So as the crypto price, which is the yellow line, as it's gone up and down, has it impacted related job openings? And this is just for Bitcoin. And as you can see, that it's just on this upward trajectory, irrespective of what the current price is. And this is as of August 2018. Here's another one. When Bitcoin peaked, what did it do to the number of postings on AngelList? AngelList is actually a European group that created, they first were doing just blockchain information, and you would post your firm to it, and they were tracking this from a geographical standpoint. But then they opened up a job board, and it continues to go up. That brings us to then this. This is the argument where we are today. There's roughly 10,000 full-time blockchain developers around the globe today. And maybe 20,000 more that do it something, but it's not their full-time job. Well, 30,000. One company, or one industry, the supply chain for aerospace. And I got this information from Airbus. I was in Germany. I was in Germany speaking, and the guy right after me was from Airbus, and he was telling these numbers. They figure that globally, to manage the supply chain for just the aerospace industry, they need 30,000 blockchain developers. Well, that's 3 times the number of available blockchain developers currently available. So 20,000 of these jobs, or maybe even 25,000 of these jobs, are unfilled at present. That brings us then to sectors. The insurance sector globally needs about 250,000. The legal sector globally needs about 250,000 blockchain developers. The healthcare sector needs about 250,000 blockchain developers globally. That's now 750,000. Let's bring in the supply chain. The supply chain for everything, it's estimated that there's 2.5 million positions that need to be filled to actually do the implementation. In 2016, we thought, okay, everybody's doing these POCs, these proof of concepts. We can actually do this. And they were testing the validity and capabilities of blockchain. But they were missing the one part. How do you do an enterprise deployment without staff? You can't even find them. They don't exist. That's why I'm in the blockchain education space. That's why Clemson is actually partnering with us to provide that type of training, is to develop the staff. This is actually an old chart. This was from Accenture in 2016, but I found it very valuable, and that is the adoption phase. We're probably shifting this by 3 years. So this early adoption of 2016, 2017 will be probably 2018, 2019, 2020, and everything will be pushed a little bit. But what you're starting to see is you're starting to see this huge adoption, and that will only happen if you manage the talent. So in getting back to one of the very first things that was brought up when we opened this, and that was, what is HR going to do? Well, guess what? HR has to hire all these people. You can't actually have any deployment without the people. So what are some of the strategies you can use for adoption? The first one is to realize this, is that if you think that blockchain is the answer to your problem, you don't understand blockchain and you don't understand your problem. Blockchain is not the answer for every single solution. So what we have is the idea that you need to embrace innovation. You need to actually understand blockchain technology and its derivatives. And you need to be undergoing constant trials, testing this out. You actually need to also realize that blockchain has been around a few years and applications are going to be discovered as we go along. One of the things that I would say more important than anything else is that anything that we envision now for blockchain will be surpassed by a factor of probably 1 million in 15 years. Think of what the internet was like in early 1990s, and then how it progressed. I mean, you look at these old websites like AOL or Disney, and they were frighteningly scary, how bad they are. And now they're so sophisticated and so smooth, and all the abilities and features and functions that we have now, that's the same progress that we're going to experience with blockchain. So the issue is that for you to do is you need to evaluate your problem. Before setting out on bringing blockchain technology into your company, you should be asking, what do you need blockchain for? And realize that there are a lot of pain points in your company, and what do you think blockchain is going to help you with? This is really the discussion you should be having, is identifying where the problems are. There's also going to be barriers to adoption. Things like legacy systems. You have to realize this. I talk about this in the financial sector all the time. There are tens of thousands of people whose entire job depends on them supporting these legacy systems. Every major financial institution has estimated 40,000 legacy systems. If you convert that to blockchain, what are these people going to do? Do you think that they're going to cooperate in terms of this migration? No, this is going to be a barrier. How you manage that barrier is going to be important. But realize there is going to be resistance to change. The issue of ability of scalability has actually been kind of resolved. With the 4th generation blockchains, we can now actually do 10 to 50,000 transactions per second. And if we string them together, you can actually have millions of transactions per second. So that's actually been resolved. Lack of compliance and regulation. This is an important aspect. I talk about compliance and regulation all the time. Whatever you think that you're going to be building, it has to comply with the existing regulatory environment. That means everything. So thinking about healthcare, what about HIPAA? Or even more so, again on healthcare, GDPR. Who even knows what GDPR is? Okay? GDPR is a regulatory environment that impacts only Europeans, but it impacts them wherever they are globally. Did you know that you're actually subject to GDPR regulations here in the US? The other issue is anonymity and security of participants and data. That's really, again, on the healthcare sector is very important, because if you do clinical trials, how do you actually manage that? Or if you're managing healthcare records, who actually owns the healthcare records? How do you actually grant permission or revoke permission in terms of who has the ability to access it? So some of the things that you need to do is evaluate the technology and realize that blockchain is not the silver bullet of every solution. But I did put this in. It's not going to solve everything, but it's going to solve most things. Again, it gets us back to this idea of what's useful and what's not useful. So here's your corporate challenge, and the challenge for you individually. The first is to realize that we live in a digital disruptive society. It's changing faster than we even imagine. And for guys like me, who's really old, it's changing even at a faster pace than in comparison to young people. But these are the things that you have to do. I'm just going to go down the list here real quick. Identify the issues, understand everyone's interests, list possible solutions, evaluate the options, select an option or options, document your agreements and agree on contingencies, monitoring, and evaluation, as well as deliverables. Look for leaps. Look for the opportunity to go from where you are today to much, much further. This isn't an arithmetic appropriation. This is a it's an exponential, right? There is, though, another cost, and that is, what is the cost of doing nothing? Realizing that every decision or indecision is a decision. You have to recognize that. The wise ones bet heavily when the world offers them that opportunity, and they bet big when they have the odds. We always underestimate the change that will occur in the next 2 years and underestimate the change that will occur in the next 10 years. Don't let yourself be lulled into inaction. Your job is to figure out what they're going to want before they do. Your option is for you to choose wisely. And when I mean that, I mean this just like this graphic shows. This is automobiles, buggy whips. You may not realize you're in the buggy whip industry. You better be ready for change. So you should start your future now. Thank you.